Hello beautiful people, and welcome to 12.1 and 12.2, which is all about matrices. Today we'll be adding, subtracting, and multiplying them. So we're given matrices A, B, and C. These are all 2 by 2 matrices. When we're talking about matrices, we will normally go rows by columns. We'll talk about the number of rows. Remember, rows go from left to right. To columns, if you look at the L in column, some people remember that the columns are the ones that you're looking at from up and down. So this is a 2 rows, 1, 2, by 2 columns. So we would like to first find A plus B. So adding them, a little bit intuitive. So you have your matrix A, and you're adding B to it. For matrix addition, it's really intuitive in that you are going to be adding all of the entries in the same position. So this 0 is in the same position as the 2. 0 plus 2 is 2. 2 plus 0 is 2. 1 and negative 4 give you negative 3. And then 3 plus 1 give you 4. That is matrix addition. Subtraction, not very much different. One thing I will remind you though is think back a few years for some of you when you were subtracting integers. Remember that you had to add the opposite. Same thing happens here. So your setup is 2, 0, negative 4, 1, minus matrix C. And so the only thing for subtraction is that you have to remember to add the opposite. Now the opposite is the opposite, opposite, opposite. You have to change all of the signs except 0 because it doesn't have a sign, obviously. And then from there you'll add the same one that you did before. So 2 plus 1 is 3, 0 and 2. 2. Negative 4 plus 3 is negative 1. 1 plus 0 is 1. That is matrix addition and subtraction. Now, example 3, you have negative 1/2, and you want to multiply that by matrix B. Matrix B was given, and this is called scalar multiplication. Scalar multiplication, and it's basically the same thing as the distributive property. So you're going to do negative 1/2 times 2. You get negative 1. Negative 1/2 times negative 4, and you get positive 2. Negative 1/2 times 0 is 0. Negative 1/2 times 1 is negative 1/2. And that's scalar multiplication. For the next one, you're going to do a couple of steps. They would like you first to scalar multiply 2 times A, and then add 3 times matrix C. Use what we just did in examples 1, 2, and 3 and try to solve number 4. Press pause now. So if you multiplied first, you got these two matrices, and then when you combine them you get negative 1, negative 7, negative 2, and 6. You can press pause if you need to see my work to double check yours. Okay, there are certain situations where we can solve for variables, and this would be one of them. Main thing here is making sure that all your positions match up. So your negative 1 is in the same position as negative 1. Great, because they are equal. But with that, we can also say that negative 3x is equal to, from this sign in the middle, negative 3x is equal to negative 18. Divide by negative 3. X then is equal to 6. Now, you can see already that the 5 is in the same position as the 5, but we don't really care about that. We want to find the y now. So this is negative 4 is equal to 2y. So y is equal to negative 2. We have found x and y. Number 6, beautiful people, I would like for you to do a little bit of simplification first. So first distribute this 2, and then combine your like terms. So distributing the 2, you have 16, 10, negative 2x, and 12, minus this matrix we haven't done anything with, so I'm just going to rewrite it. And now, remember that for when we are subtracting, my bad, we will be adding the opposite. So add opposite, 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 and opposite. Combining like terms, 16 plus negative 3 is 13. 10 plus negative 10 is 0. Negative 2x and plus 9, we don't know. Can't combine those. So I'm just going to write it as an expression. Same thing, 12 plus 4y. But all of this will help me because I do know that the right side of this is equal to that. So this is that 13, 4, 0, and 16. Checking myself, 13 is in the 13, 0 is with the 0. So negative 2x plus 9 is equal to 4, and 12 plus 4y is equal to 16. And then you can solve each of these. Subtracting 9, you get negative 5. Something is a little bit off. This was 9. My bad. No, I was right. I should have brought this down. I just lost my spot there. This was the 9 that I got confused for that one. So I get negative 5. And when I subtract 9 and subtract 9, so x is equal to 5 over 2. And then for this one, I will subtract 12 on both sides. And I have 4y is equal to 4, so y is equal to 1. All right, love it. So that was 12.1, and then part of 12.2. The other part of 12.2 gets a little bit to a point where we got to focus a little bit more. So the rules for multiplying matrices. What we did in the last one was scalar multiplication. It's nice and kind of user-friendly. I'm going to remind us that when we're talking about dimensions, we're talking about rows by columns. So the number of rows by the number of columns. In order for us to multiply matrix A times matrix B, and then notice we're using cap locks here, or capital letters, it's because to denote that something is a matrix and not just a number, that's why we use the capital letters here. So the dimensions, DIM, dimensions of A is M by N, so M rows by N columns, and the dimensions of B would be N times some number P. To multiply, in order to be able to multiply, you have to make sure that these two numbers match up. When they do match up, it's kind of like they cancel out, and so your result would be an M by P matrix. You're going to see that in just a moment. But in order to multiply, beautiful people, you have to make sure that these dimensions work out for you. They have to be the same number, which is what this is basically saying. So let's try this with variables first and see how we do. First of all, this is a 2 by 2 matrix, 2 rows by 2 columns. And this is 2 rows by 2 columns. So these two numbers match up, which is great. My result should be a 2 by 2 matrix. Okay, let's check it out and let's see. So follow me. We're basically, it's not intuitive at all. We're going to take this row right here, which is your EG. And what we're going to do with that is we're going to multiply it here and here. We're going to take that EG and we're going to multiply it. So this column gets multiplied here and here. So what would that look like? Well, it looks like this. So here you are, you have the A. Here are the rules for multiplication. AE plus BG. And then you take that and then you take it to the next one as well. So what do you have? You have CE plus DG. And then you do the same thing with the other one. You're going to take this FH and you're going to multiply it to the same thing. The rows, you're going to distribute it to each row and each column. So this FH, you know, this is really high tech. You feel it. And you're going to multiply it here and here. So what are we doing? We're going to get AF plus BH. And then for the next one down, the next row will be CF plus DH. And I kind of checked myself a little bit because I do know that I had A, B, C, D. A, B, C, D. And then I'm multiplying by EG, EG. I have the same A, B, C, D, and the next one was FH, FH. That's kind of like something you're going to kind of just check yourself and make sure you're okay with. So let's try to multiply, shall we? Say yes, yes. So first, can we? I don't know. What are my dimensions of this first one? Well, this is 3 rows by 2 columns, because there's 1, 2, and the next one is 2 by 2. So these match up. My result should be a 3 by 2 matrix. Let's see how that works. So we're going to do the same thing that we just did. And I'm going to start with this -2, -1, and I'm going to distribute it. So we have -2, -1, -2, -1, and I'm going to take that -2, 1, and I'm going to hit every term in here. Give yourself some space, or write a little bit smaller actually. So the first one, there's -1 times -2 plus 5 times -1. Taking it down to the next one, I have 5 times -2 plus 4. I'm sorry, just kidding, 2 times -1. Keeping you on your toes. The next one, I have 0 times -2, my handy dandy teaching aid there, plus 4 times -1. And I'm checking myself, -2, -2, -2. There should be a pattern if I'm being consistent, -1, -1, -1. Good. And then you're going to do the same thing with the other row, which was -1, -3. So I'm taking that -1, -3 from here, and I'm rotating it in my head. I don't mind if you use these, by the way, because matrix multiplication can be a little bit tricky. So not a bad idea to do this. I have -1 times -1 plus 5 times -3. 5 times -3. Then you're going to do the same thing, drop it down. I have 5 times -1 plus 2 times -3. Break it down one more time. I have 0, -1 plus 4, -3. Good. And then I'm making sure -1, -3, -1, -3, -1, -3. And then these match up with these, and then these numbers right here match up with, I'm sorry you can see that, these numbers right here. From here, beautiful people, you use a little bit of your arithmetic skills and you add and combine like terms and whatnot. So for this first one, -1 times -2, that's 2 plus -5, so I get -3. For this one, this is -10 plus -2, so -10 plus -2, I get -12. This is 0 plus 4 is -4, sorry, is -4. And then you simplify your other column as well. You don't have to use 2 different colors, but I think it's helpful sometimes visually. And I get 16. No, I don't. I get 1 minus 15, so I get -14. You can check my math and make sure. -5 minus 6, I get -11. And then what is this? 0 minus 12. -12. Close it up. Oh my god, those, you couldn't see any of that. So this is what I got for each one. You can check my arithmetic. The main thing is knowing where these numbers came from. Sorry about that. Okay, last one together. Now, we're going to distribute, so we want to multiply matrix. Bummer. Bad teaching skills. Matrix B times the sum of A plus C. So you can press pause if you haven't written this down yet, but this is what we're going for. This is matrix B times A plus C. First thing I'm going to do, order of operations, the parentheses, is I'm going to combine these two first. So this will stay the same. That's matrix B. But when I add this matrix plus this matrix, I'm going to have 2 plus 0 is 2, 1 plus 2 is 3, -2 plus 3 is 1, and 4 plus -1 is 3. Now, this is a 2 by 2 times a 2 by 2, so I can multiply these quite nicely. Okay, so you might need to press pause, but for 2, 3, I'm multiplying 0, 1, and then -3, -2. So go ahead and press pause if you need to, just so you can see that and write that down. And then after that, you're going to go for the other one and distribute the 1, 3. Try that one on your, so your next row, you do the 1, 3 here, so 0, 1, and then here as well. Different color coding for this one. And then you'll simplify. So when you multiply and add, you get 3, 3, -12, -9. 0 times 2 plus 1 times 3, and this is my result. Color coding does kind of help, so I color coded in 2 different ways to help you out. I would like for you to try letter B on your own, and you should get the same answer that you just got now. Thank you.